Good morning, everyone. I'm going to try to meet my deadline in 8 minutes, so it's going to be fast. I'm actually an assistant professor at Telecom Paris. So as you could guess from the name and from my accent, I'm from France. And I'm going to present the tools we are developing around AADL, but as you probably understood already, our main projects, if I can use this word, are diplomas and research work. But we also prototype our research work into tools that we maintain when we have demand, and we have maintained some of them for a while, and they have get matured. If some of you want to try them and give us some feedback, we are willing, or we would be happy to help you using and evaluating these tools. So we've heard a lot about virtual integration today, and when we talk about virtual integration, what comes to my mind is, on one hand, functional integration. So how does my software behaves? And doing this virtually means we're going to simulate the behavior. We're going to do this, or try to do this by including the operating system and the full stack of software. So that's one part of our work. And the other part is performance. When we think about integration issues, we often hear from our partners that one of the main issues they face are performance issues. So we're going to try also to provide some timing analysis tools and integrate those the functional integration on the one hand and the timing analysis on the other hand. I'm going to present three different works we've been working on. One of them is called Ramesses for refinement of AADL models for the synthesis of embedded systems. So I'm not a fan per se of Egyptian history, but the name or the acronym felt right with respect to the purpose I'm going to describe just after. Then the more advanced research work on mixed criticality directed acyclic graphs for scheduling task sets on multi-core architectures. And the last brief presentation I will give of the tools we develop is about switched Ethernet flows analysis. And other tools are also described on our tools webpage, but I'm not going to talk about them today. So what is Ramesses? Ramesses is a tool to automate model transformations from AADL to AADL. So we're going to start from an AADL abstract model and automatically transform this AADL model into a refined version of this. The reason we do that is that we believe, and this is most often the case, that analysis can only be performed as a given abstraction level. So when you have enough information in your model, you can start doing schedulability analysis. But before that, you could already have done flows analysis at the network level, typically. And these are different abstraction levels. Another reason why we're doing that is that when you go from an abstract level to its implementation, you actually do an interpretation. You have the abstract model in AADL, and the interpretation you do is by transforming mentally the abstract information, the connections, for instance, into buffers or shared data. And this will have an impact on the analysis results that you have at the end. So what we want to ensure is a reduced semantic gap between what you have at the end of the interpretation, which is the software, and the analysis result that you do on the model. And to do that, we will progressively refine the AADL model into the most precise we can have until we do the analysis. So the tool itself is an add-on to OSATE, so you can directly download it on the update site that we provide. So you can install it within OSATE. It takes 2 minutes. It's available on our webpage, and you can find the instructions there. Just to try to clarify or to precise a bit the ideas I was presenting before, I was talking about before, you have on the left side here a design model where all the data flows are representing with connections. And you have on the right side an implementation of this model. And this is actually the level of abstraction we believe it is interesting to do the timing analysis, because there we have introduced shared data, which will have an impact on the timing performance eventually. So you can do the analysis on the design model, you can do it on the implementation level. I don't expect any of you to try to write a model as it is shown on the right side, because it's quite difficult to understand. It's troublesome to write. So what Ramesses is going to do, it's going to interpret automatically the model on the left side and produce, by a model transformation, the model that you have on the right side. And then it's going to apply timing analysis on it by calling AADL inspector, which is shown on the bottom left on the slide. And then it's going to interpret, again, this model to produce the actual C or ADA code. Right now, the supported platform for code generations are POSIX, which means Linux. So you can simulate your AADL model directly on your host computer if you have a Linux platform. We also support RN653 standard, and you can simulate RN653 operating systems with their software on top of it using the POK, which is an open source implementation of RN653. And you can again simulate it on your host platform, which means on your development computer. And we also support OSEC, which is a standard that is used in automotive. More recently, we have developed a support for distributed systems, both on POSIX and RN653. We also support local modes management, which means if you have applications with different modes and different configurations in each of these modes, we can generate code for them. The tool is being used by two big companies in France now. One of them is Safran in research and development activities, and we believe this tool has high potential in terms of transfer, as we are now able to deal with quite complex systems. Their application is made up of 6 different processors and 21 applications. So we generate the code for this on RN653 systems in something about 5 minutes. And we support most of the concepts of AADL, and if there are some concepts that we don't support and you want us to extend our tools, please give us some feedbacks when you have tried it. The demo I'm going to do today is based on a toy example. So this small robot is hiding in a box somewhere in the room, and it's going to show up during the demonstration. It's, of course, a very small toy example in which I'm going to illustrate the complete transformation and analysis cycle that I was showing before. So we're going to start with the design model and then produce the implementation model, analyze it with the AADL inspector, and generate the code so it actually follows the line and stop if there is an obstacle. Everything is very well documented on this example. If you want to try it or extend it with your own tools, for instance, by providing a better model for the hardware part, you could illustrate your tools on it, and the complete demonstration source is available on our website with a complete tutorial that explains how to use it. So I'm a bit late, so this I'm going to pass a bit on it. I mean, it's more on research work that we have done in 2018, and that's been integrated on Ramesses. But the potential transfer is a bit far away for now, so I'm going to focus on that part instead, which is the switched Ethernet flow analysis technique, which means we have implemented an analysis tool for AADL to analyze worst case end-to-end latency on switched Ethernet networks, which means typically AFDX network, which stands for Avionics Full Duplex Ethernet. And this is a very simple example, but on the website you can also find an example that is inspired from a real industrial case study. This small example shows that with AADL you can model your network architecture with different switches as devices, the different nodes as processors, and the flows as virtual buses. And then you can provide a bit more information about timing aspects of these different components. Click a button and get an Excel file that will tell you which is the end-to-end flow that takes longest to go from one end to the other, and why there is some delay incurred by different messages going through the same path. Okay, to summarize, you will find different information, description, and instructions to install and play with our tools on our webpage that is referenced here. I would be very, very happy if I had any feedback from you on these different tools. So don't hesitate. And if you want to have more information about the tools, and if you want to discuss about the different technologies we provide or the different research work we can do, please come to my giant booth. Mine is also very big for the demo and discussion. And now we can go and have lunch.